Hey there, welcome to Brainy Hub. Today we are going to learn about trees and binary trees. We will also learn about their implementations in Python. So let's get started. A tree is a hierarchical data structure made up of nodes. For example, this is a tree where we have a total of 6 nodes. Now each of the circles with values inside them are known as nodes, and the topmost node is known as the root node. So in this tree, the root node is node number 1. Now each node contains a reference to its child node. For example, if you look at node 2 and node 3, these two nodes branch off node 1, meaning they are children of node number 1. Node 1 will be considered their parent. And finally, the nodes that have no children, meaning the nodes at the bottom like 4, 5 and 6, these are called leaf nodes. So that is the basic terminology about trees that you should know. Now that we know about trees, let's learn about binary trees. So binary trees are trees where each node has at most 2 children. It can have no children, 1 children, or at most 2 children. It cannot have more than 2 children. So that is known as a binary tree. For example, in this binary tree, the root node is 1 and 1 has 2 children. The first children is node number 2 and this is known as the left children. The second children is node number 3 and this is usually known as the right children. And node 2 and 3 have their own children as well. And finally, node number 4, 5 and 6 are known as leaf nodes as they have no children of their own. Now that was the basics of binary trees. Now let's look at some tree traversal methods. There are 3 main tree traversal methods. The first one is pre-order traversal. In this traversal, what we do is we first visit the root node and then the left side of the tree and finally the right side of the tree. These are also known as the left subtree and the right subtree. The second type of tree traversal is in-order traversal. In this, we first visit the left subtree, then we visit the root node, and finally we visit the right subtree. And the third main tree traversal method is post-order. In this, we first visit the left subtree, then the right subtree, and finally at the end we visit the root node. Now the time complexity of tree traversal is big O of n, where n is the number of nodes inside our tree. This is because we visit each node exactly 1 time. Now let's look at this practically in code. To create our trees, first we need a class for nodes using which we can create nodes. So let's do that. I'm going to create this class and the name is just going to be nodes. And inside the init function, we are going to have a couple of parameters. So the first one is just going to be the value, which we are just going to pass on right over here. The second one is going to be a left child, and by default that's just going to be none. And the final one is a right child, which also is going to be none by default. Now that we have the class for our node, let's create the class for our binary tree. So I will create the class and I will name it binary tree, and inside the init function we are just going to create a root. So self.root equals to, we are going to create a node by using the root value, and we are also going to get the root value as a parameter. Now after that we should create a function for inserting a node inside our binary tree. So to do that, I am going to create this function called insert, and this is going to just take the node which we are trying to insert, and I will call this value instead. And in here first we are going to check if our current binary tree does not have a root, then we are just going to set the root to be this value. So we are going to create a node with this value and set it as the root. As the tree is empty, so we'll just insert it as the root. If not, then we are going to code the functionality for inserting a value inside our tree right over here. So what I'm going to do is I will have a list called nodes, and this is going to have the self.root. Now the reason I am doing self.root is because I can reach every single node by just starting from the root. And now what we are going to do is we'll have a while loop, and it is going to run till we run out of nodes. And in here what we are going to do is we are going to try to find a node which has either no left child or no right child. And once we find that, we are just going to insert our value as either the left child or the right child. So let's do that. So we'll pop from our nodes. So current equals nodes dot pop of 0. Now what pop does is it pops a value from a list, meaning it removes that value. And when we provide 0, this means it will remove the 0th index, and we are storing that inside the current which we are going to use. Now we will check if our current node that we are on right now has no left child, meaning its left child is empty and there is a free space where we can insert our node. Then we are just going to set the left child of our current to just be our current value, and we are going to convert that to a node and set it to the left child of the current. And then we are just going to return, which is going to jump out of the function as we have finished inserting the value. Now if that isn't the case, then we are going to append whatever is in the left of our current node inside our nodes, as once this iteration is finished and we don't find an empty space, then we are going to check that node and see if that has any empty space for the left or right child. So inside our nodes, I'm just going to append the current.left, and this will only execute if the left is not empty, because if the left is empty, then we are just going to set it to our current node and then return, which is just going to exit out of the function. Now we will do the same thing for the right node. So if our current does not have a right child, then we are going to set its right child to be our current node, which is going to insert that, and then we are just going to exit out of the function. But if that isn't the case, then we are also going to append the right children of our current node inside our nodes list, like so. And this is going to run till we find an empty space, and then once we find an empty space either in the left side or the right side, we are just going to append our value, which is going to insert it inside our binary tree. Now that is the insert function complete. Now let's implement our tree traversal methods. So the first one we'll code up is the pre-order traversal, and this is going to take a starting node and a result list. The result list is just going to be an empty list inside which we are going to store the result. So first we will check if our starting node is not empty, then we are going to start traversing our tree. If it's empty, then it's not going to do anything and we will jump out of the function. So in pre-order traversal, we first traverse the root, then the left subtree, and finally the right subtree. So let's do that. First we will traverse the root, which is just going to be our starting node, which is node. So inside our result, we are just going to append node, meaning we have visited this node. Now after that, we are just going to call this function pre-order traversal, and we are going to pass it the left subtree, and the result is just going to be the same array, and we will call it again for the right subtree, like so. And don't forget to put self here, so self dot and self dot. So this is going to use recursion, and the function will call itself on the left subtree, and the starting node is just going to be the left child of the root. Then it is just going to append that inside the result and call the function again on the left subtree of that till there is no left child. Then it is going to do the same thing for every single right child. So it is going to recursively traverse the entire tree. Now if you are not familiar with recursion, then I recommend you watch a couple of videos on it and then come back here, and this will all start making sense. Now let's code up the second tree traversal, which is in order traversal. So this is going to be very similar as well. So we are going to take a starting node and a result. Again we are going to check and make sure that our starting node is not none, and then what we have to do is we first have to visit the left subtree, then the root, and finally the right subtree. So for the left subtree, we are just going to call this function on itself, so recursion self dot in order traversal, and we are going to provide the left subtree and the same result list. Then once it has traversed the entire left subtree, then we have to visit the root. So inside the result, we are just going to append the node, which is the root, and finally we are going to call the function again on the right subtree, like so. And now we have to code up the final tree traversal, which is post order traversal. This again is going to take a starting node, which is going to be the root, then a result, and again we will make sure that the root is not none, and in this we first have to visit the left subtree and the right subtree and finally the root. So let's do that. First we are going to call this function on itself for the left subtree and provide the same result list. Then we are going to call it for the right subtree as well, and finally we are going to append our root, which is just the node. So this is going to traverse the left subtree, then the right subtree, and finally it is going to visit the root. So we are done with the binary tree class. Now let's test it. So I'm going to add a couple of nodes here. These are going to be the nodes. So first we are creating a binary tree with 1 as the root node, and then inside the root node we are adding a left child, which is going to be 2, and for the right child we are adding 3. Then for the left child of the root we are also going to add a left child to that as well, which is going to be 4, and for its left child we are also going to add a right node, which is going to be 5. Then finally for the right node and finally for the right child of the root we are just going to add another right child, which is going to be 6. Now let's test the insert function. So inside our tree I'll insert 7 and 8 as well. So this is how the tree should look like. And this will be the test case for the pre-order traversal, in-order traversal and post-order. So I'm creating an empty result list for each of them, and then I'm passing in the tree root and the empty result list, and once that's called I'm printing the result, and then we are doing the same thing for each of them. Now before running the code I've noticed a flaw. So in the tree traversals we should append the node dot value, which will append its value, but if we just append the node then it will append its class object, which is not what we want. So in here update it to dot value, which is just going to append the value of the root each time. And now if you run the code, as you can see it performed all of the traversals, and 7 and 8 have also been inserted inside the tree. That's a quick overview of trees. If you found this video helpful, don't forget to like and subscribe for more content. I'll see you in the next lesson.